Today we'll go ahead with some of the important problems of permutation. If there are n letters, you can arrange them in n factorial ways. There are 9 letters, you can arrange them with 9 factorial. This one unit, whatever we have taken, one unit I took this ovals 1, 2, 3, 4, 5. The number of permutations of the letter word committee in how many ways? No two ovals are together. Welcome to the session, dear students. Today we'll go ahead with some of the important problems of permutation. See, these are all standard 3 markers. Find the number of permutations of the letters of the word committee, and they have given sub questions. How many of them begin with T and end with T? How many ways all ovals are together? In how many ways no ovals are together? How many ways of them end with MITE? These are the questions. See, first, number of permutations of the word committee. Say, if you count, there are how many letters in this? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 letters. In which repeated letters we have. M repeated 2 times. 2 M's are there. 2 M's and 2 I's. 2 I's and 2 E's. Means E repeated 2 times. There are 2 M's, there are 2 I's, there are 2 E's. There are 2 M's, 2 I's and 2 E's. So therefore, number of permutation, total number of arrangements. So therefore, find the number of permutation. Means the first question answer is total number of arrangements or total number of permutations is equal to total. How many letters are there? 9 letters. So 9 factorial ways. If there are n letters, you can arrange them in n factorial ways. There are 9 letters, you can arrange them with 9 factorial. If no letter is repeated, answer is 9 factorial. But m repeated 2 times, so in denominator 2 factorial. And I repeated 2 times, again 2 factorial. Again E repeated 2 times, 2 factorial. So total number of permutation. So for this part, total number of permutation answer is what? 9 factorial divided by 2 factorial into 2 factorial into 2 factorial. Why? Because in the word committee there are 9 letters. 9 letters can be arranged in 9 factorial ways if there is no repetition. But M repeated 2 times, so 2 factorial in denominator. I repeated 2 times, so 2 factorial in denominator. E repeated 2 times, so 2 factorial. So because M, I and E repeated, so if any letter repeats, then we'll have. So what is the number of permutations formula? N factorial by P factorial, Q factorial, R factorial, so on. So here N factorial means total number of letters in the word. P means if any letter repeated P times. See here M repeated 2 times, so 2 factorial. And Q means any other letter repeated. So I repeated 2 times, so 2 factorial. R means 2 factorial, like that. 9 factorial by 2 factorial into 2 factorial into 2 factorial is the total number of permutations. Then, so now the first part we have done, total number of permutation I have done, that is 9 factorial by 2 factorial. So now how many of them begin and end with T? So first place and last place is T. Other than that, we have in between, to see 1 to 9 places were there. In 9 places, you have filled 2 places with same letters. So remaining 7 places are there. So in 7 places, 7 letters other than T, 7 letters can be arranged in. So if I remove T, I'll have 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are there. Though there are 8 letters, I have 7 places. So in 7 places, I can fill 7 letters in 7 factorial ways. And because only in between I have 7 places, 1 place I cannot repeat, then in that 2 times E repeated, 2 times M repeated. So M repeated 2 times and I repeated 2 times. So E repeated 2 times. So I can write 2 factorial. Then other than that, the number of permutations of the letter word committee, in how many ways all ovals are together. All ovals are together. See, first in committee, what are the ovals here? So ovals, how many ovals are there here? O is a oval and I is a oval, and that I repeated 2 times, and E is a oval, again E is a oval. 1, 2, 3, 4, 5, oh sorry, 5 ovals are there. O is one oval, I is another oval, I is another oval, E. Total 5 ovals are there. So 5 ovals, I should take them as 1 unit. So now together they told. So consider 5 ovals as 1 unit. As 1 unit. Now other than ovals, so 5 are ovals. Remaining are consonants. Remaining are not ovals. What are the remaining? See, we have total 9 letters. In 9 letters, 5 if I remove, I have remaining 4 letters. So now total 4 non-ovals. Non-ovals means what? Consonants. And 5 ovals as 1 unit. 5 ovals as 1 unit if I take. Therefore, total we have 4 plus 1. This put together we call it as 1 unit. 5. So 5 letters can be arranged in 5 factorial ways. So number of permutations, number of, how many words they told, or number of ways or number of permutations is equal to, we have 5 letters now, 4 which are not ovals. 4 which are not ovals can be arranged in 4 and 1 oval, I will take it as 1 unit. Total I have 5 units, and that 5 units can be arranged in 5 factorial ways. This 5 as 5 factorial, but in that 4, so non-ovals, what are the non-ovals? So non-ovals which are not ovals, non-ovals are, we say, consonants. Non-ovals are consonants. What are the consonants we have? Consonants here, C is a consonant, M is a consonant, again M is a consonant, and T is a consonant. C, M, T. So now in this non-ovals I have 2 letters repeated. So 5 factorial by 2 factorial into this 1 unit, whatever we have taken, 1 unit I took this ovals 1, 2, 3, 4, 5. So that 5 separately I can take them as 5 factorial divided by, in this we have repeated 2 factorial into 2 factorial. So total number of ways in which 5 ovals are together, or how many ways ovals are together? I have total 1, 2, 3, 4, 5 ovals. 5 ovals I will take it as 1 unit out of 9 letters. So we have 5 ovals and 4 non-ovals. 4 non-ovals has 4 different letters, 4 letters, and 5 ovals is 1 unit, 1 letter. So 4 plus 1, 5. 5 can be arranged in 5 factorial, but in this we have repetition. So 2 are repeated, 2 factorial, and the ovals separately I took 1 unit, right? This 1 unit is made up of 5, so that's why this 1 unit can be arranged in 5 factorial by 2 factorial into 2 factorial. So this is the answer. Then the number of permutations of the letter word committee, in how many ways? No 2 ovals are together. 2 ovals should not be together. So means other than ovals I have C, I have M, and again I have M, again I have T. So C, M, again 2 M's are there, yes, and T. 1, 2, 3, 4. 4 letters are there. For 4 letters, we'll have 5 alternate places. 1, 2, 3, 4, 5. So if ovals are not together, no 2 ovals should be together, means they should not be together, means not, see, how many ways? No 2 ovals are together. 2 ovals should not be together, means oval should be between the consonants. So means they should be in the alternate places. See, there are For 4 letters, we'll have 5 alternate places. There are 5 places where vowels can be filled, vowels can occupy, so that they'll not be together. So that they'll not be together. They'll not be together. So now I have 1, 2, 3, 4, 5 places. In that 5 places, I have to fix vowels. How many vowels we have? 5 vowels we have. So we have O, I, E, E. 1, 2, 3, 4, 5 vowels are there. So 5 vowels. So in 5 places, I can occupy, I can arrange. So cannot be together. Therefore, number of permutations or number of arrangements or number of ways, we can say, is equal to, see here, 1, 2, 3, 4. These 4 non-vowels can be arranged in 4 factorial. In that 4 factorial, 2 m's are repeated, so by 2 factorial. And I have 5 vowels in 5 places. 5 vowels in 5 places can be arranged in 5p5 divided by, if anything repeated, yes, vowels are also repeated, 2 and 2, 2 factorial, 2 factorial. So 4 factorial by 2 factorial into 5p5 by 2 factorial into 2 factorial is the answer. Then we have, so here, how many ways? They end with MITE. So MITE is fixed. MITE is fixed. So other than MITE, I have 1, 2, 3, 4, 5 letters. 5 letters. So therefore, since word ends with MIT, so this is fixed. So there is no chance to arrange this. So it is fixed. All the words are ending with MIT. So remaining, I have 1, 2, 3, 4, 5. So remaining, other than MIT, remaining, so in COMMITIEE, in this, 1 M I will remove, 1 I will remove, 1 T, 1 E I remove. So I'll have, other than that, 1, 2, 3, 4, 5. So remaining 5 letters can be arranged as in 5 factorial ways, provided in this C, what are the letters? C, O, and I am left out with M, I am left out with I am left out with E. 1, 2, 3, 4, 5. So all 5 are different. So 5 factorial. So therefore total number of ways is 5 factorial ways. You know 5 factorial is what? 5 into 4 into 3 into 2 into 1. Okay. Now, how many 5-digit even numbers can be formed from the digits 0, 1, 2, 3, 4, 5. So they wanted to form 5-digit even numbers. So 5-digit even numbers, 5 places, units, tens, hundreds, thousand, 10,000. See, even number means it should end with even number. So the last place, here units place, I can fill in units place to get an even number. If you want the number to be even, to get an even number, the last place means what? Units place. To get an even number, units place can occupy, out of the given digits, it can occupy 0, it can occupy 2, 4. Occupy 0, 2, 4. 3 ways. Means you can fill the units place, this place, in 3 ways. And if you want 5-digit number, you can fill they have given 1, 2, 3, 4, 5, 6 numbers are there. I can fill in 6 ways, but I cannot fill 0 in the first place. So other than 0, I can fill the first place in 5 ways. So there is other restriction. To get a 5-digit number, the first place means here units, tens, hundreds, thousand, 10,000. 10,000th place, or I'll say first place, cannot be filled with, can't be filled with 0. So 0 I cannot include. So other than 0, I have 1, 2, 3, 4, 5. 5 ways I can fill. But here there is no restriction. Here I can fill any of these 6. And they told without repetition, with repetition they have not given. So that's why here I can fill any 6 numbers. Here I can fill this in 6 ways. I can fill 0, 1, 2, 3, 4 or 5. Here also I can fill in 6 ways. So they want total number of 5-digit numbers. Therefore, total number of 5-digit even numbers. 5-digit what numbers? Even numbers. Even number means they should end with even number. That's you can fill these three ways in the first place. Total number of 5-digit even numbers is equal to, by fundamental principle of counting, multiply all. 5 into 6 into 6 into 6 into 3. Use calculators, multiply and write the answer. Or 5 6 is 30. 30 into 6, 180. 180 into 6 into 3. Do the multiplication and write the value. So logic, if you are thorough, more than enough for me. Then multiply madi, you can use calculator or multiply it and write. So, but what is the restriction here? First place has to be filled only in 5 ways. You cannot fill 0. Second place, no restriction. There are 6 numbers, any 6 you can fill. And because they told, they have not given that without repeating the numbers. If they tell without repeating the numbers, then I have to decrease 5, 4, 3 like that. I hope all of you understood this. Multiply that, you will get the final answer. In how many ways the letters of the word accountant be arranged? In how many of them ovals are always together? So total number of ways they want, and how many ways the letters are together they want. So now total number of permutations. Total number of permutations without any restriction. Number of permutations. Total number of permutations. See, in accountant, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters are there. In accountant, there are 10 letters. There are how many letters? There are 10 letters exactly. In the 10 letters, we have repeated letters. So, C repeated 2 times. We have 2 C's. And O is not repeated. N repeated 2 times. We have 2 N's. And also, A repeated 2 times. We have 2 A's. 2 A's, 2 C's, 2 N's. Now, total number of permutations is equal to, how many letters are there? 10 letters are there. 10 letters can be arranged in 10 factorial ways. 10 letters can be arranged in 10 factorial ways if there is no repeating of any letter. But we have repeating of letters. So, A repeated 2 times, that's why divided by 2 factorial. C repeated 2 times, that's why divided by 2 factorial. N repeated 2 times, that's why divided by 2 factorial. This is the total number of permutations. Then, second part. In how many ways ovals are not together? First, out of 10 letters, we have ovals. What are the ovals? O, A, O. So, ovals we have A. Again I have O. Again I have U. Again I have A. So, there are 4 ovals. 1, 2, 3, 4 ovals. That's it. 1, 2, 3, 4 ovals. So, in accountant, we had 10 letters, but in the 10 letters we have ovals. 1, 2, 3, 4 ovals are there. So we have 4 ovals. What are the A, O, U, again A. And non-vowels are consonants. Consonants, how many are there? Remaining. So, remaining we have 6 consonants. What are the 6 consonants? 6 consonants are C, again N, again T. These are 6 consonants. How many ways 2 vowels are not together? What they want? How many ways the vowels are? How many ways vowels are together? They want vowels to be together. So, vowels together. Number of ways in which vowels are together. Number of ways in which what? Vowels are together. Vowels together. Vowels are together. It's interesting. Vowels together means I'll take vowels as one unit. See, other than 1, 2, 3, 4, 1 unit. This vowels I'll take it as 1 unit. And we have remaining 1, 2, 3, 4. So we have 2, 4, 5. C, N, T. Okay, T also repeated 2 times. T, 6. So now 1, 2, 3, 4, 5, 6. 6 letters are there. So now see here 6 letters. So total number of letters we'll say. Total number of letters. So now total number of letters varies. So 6 non-vowels, 1, 2, 3, 4, 6 plus vowels I will take as 1 unit, 6 plus 1, 7. So now vowels together means I can arrange, now I have 7 because all vowels are 1 unit. Other than vowels I have 6, 6 plus 1, 7. 7 letters can be arranged in 7 factorial. But in that 7 factorial, so these 2 C's are there, 2 N's are there, 2 T's are there. So I'll have divided by 2 into 2 into 2. And separately this 1 unit vowel again has 1, 2, 3, 4 letters. That 4 letters I can arrange them in a 4 factorial. But here again I have A repeated 2 times. 7 factorial by 2 factorial into 2 factorial into 2 factorial is the arrangement. And the vowels separately, see 1 unit vowel, again I can jumble the vowels there like this. So this is the total number of ways. If you want together, call them as 1 unit. Here vowels are together means I have 1, 2, 3, 4 vowels. 4 vowels take it as 1 unit. Other than 4 vowels I have 6 letters. So 6 letters plus vowels are 1 unit, 7. So 7 can be arranged in 7 factorial. But in this 7 we have 2 C's, 2 N's, 2 T's. So 2, 2, 2 comes. And the vowel, 1 unit vowel, whatever you have taken, that is made up of 4. That separately will take 4 factorial. In that vowels again I have A repeated twice. So divided by 2 factorial. So this is the answer. You can further simplify or leave it. They will give full marks. I hope all of you understood the standard problems of permutation. I will see you in my next session. Thanks for attending. Thank you.